Hello guys. So today in this video I'm going to explain about acceleration due to gravity. So this is also a very important question for the SE examination. Okay, almost in every year this question is asked. So let's understand what is the meaning of acceleration due to gravity. So let's start. So मैले यहाँनिर definition लेखेको छु. The acceleration produced on a falling body due to the gravity is called acceleration due to gravity. It is denoted by small g and its value is 9.8 meter per second square. So यहाँनिर मैले इसको definition लेखेको छु. So as we all know that if we drop something from certain height, its velocity goes on increasing and increasing. So that increasing speed is called acceleration, and acceleration in presence of gravity is called acceleration due to gravity. So I have drawn a figure here. Okay, in this figure we can actually see the speed increasing. Initially the velocity is 0. In first second the velocity is 9.8 meter per second. In second the velocity increases and becomes 19.6 meter per second, and as the time increases, in fifth second the velocity becomes 49.0 meter per second. So this is very huge speed. Okay, with this speed anything can be burned. That's why whenever asteroid enters into the Earth's atmosphere, it gets burned up. Whatever drops from the space, that get burns up, because with this velocity the frictional force generated is very much, which produces a lot amount of heat that burns up the thing. Okay, so this is the meaning of acceleration due to gravity. Okay, so in this topic we also need to understand the difference between capital G and small g. So many students feel very difficult. Okay, many students feel very difficult in these terms. Okay, they don't know the meaning of these terms. So let's study, let's know it properly. There are many differences between these two terms. So what is meant by capital G? We all know that it is meant by, like, the meaning of capital G is universal gravitational constant. Okay, it is the universal gravitational constant. It is just a proportionality constant which comes in a derivation, and the meaning of small g is acceleration due to gravity. Okay, it is the acceleration produced on a falling body. So let's see the difference. In the first number, like, we just write the definition. Okay, here you can see the definition. The definition of capital G is, it is the force of attraction between two unit masses separated by 1 meter. Unit masses means 1 kg masses. Now let me show you. I have drawn a very simple figure here. If we consider two masses each having 1 kg of mass and they are separated by 1 meter distance, then the gravitational force between these two bodies is called capital G. Okay, it's called universal gravitational constant. So if the definition of G is asked, you can write here. You can write the definition. You will get full marks. Okay, and what is the meaning of small g? I have already written here. Okay, in the second point we can write, like, it is constant at every place in the universe. Obviously the value of capital G is constant at every place of the universe. This is the meaning. This is the value of capital G, and this never changes. And the value of small g is not constant. It changes place to place. Okay, like in the poles of Earth and in the equator, it is not same. It depends on the radius. Okay, if the radius of the Earth increases, the value of g will decrease. So the third point is value. Okay, here the value of capital G is given, that is to be 6.67 into 10 to the power minus 11 Newton meter square per kg square. But the value of small g is 9.8 meter per second square on the sea level. That means on the sea level the value of small g is 9.8 meter per second square. But as we move to other places from sea level, the value might differ. The fourth one is, it is a scalar quantity. That means the capital G is scalar quantity and small g is vector quantity. Now what is the meaning of scalar quantity and what is the meaning of vector quantity? That, like, scalar quantity means having only numerical value but no direction. The value of capital G has numerical value. You can see this is the numerical value, but it doesn't have any specific direction. But small g have both, like it has numerical value as well as it has direction, because the earth pulls everything towards its center. Okay, so that is a direction towards the earth center. The fifth difference is its unit. The unit of capital G is Newton meter square per kg square, and the unit of small g is meter per second square. And there are many more differences that you can also understand. I feel this too easy. I feel this easy. These differences easy to understand. Okay, so this will help you. If this question is asked, you need to write this much. So if you like my video, please subscribe the